keeping track of climate change with swarms of collaborating mini-satellites, scanning the universe for life on exoplanets, and providing secure, high-bandwidth communications for all. These are some examples of what we work on at the Department of Space Engineering. Let's meet some of their people and have a look at their labs.
Welcome to the clean room. This is the cradle of our spacecraft. With equipment in here, such as a vacuum oven, Helmholtz cage used for testing attitude control systems of nanosatellites, we build and test our own spacecraft. We can even monitor our satellite because we have our own ground station. Here you can see Delphi PQ flying over. It's one of our labs in space, and it's the smallest of all. It's only 5 by 5 by 17 centimeters. These tiny satellites are designed to work in swarms, for example for Earth observation or for providing fast internet connection.
None of this work could be done without excellent space instrumentation. Professor Jérôme Louic heads the new Space Instrumentation Lab. This optical table, for example, is equipped with interferometers to measure the chemical composition of the atmosphere, such as traces of greenhouse gases. Let's go up a few floors and see what's on the roof.
We're at the top of the Aerospace Engineering building. It's a little bit windy today. As you can see, there is a frame. This frame will be removed and we will build our optical ground station for laser satellite communications and also for laser satellite ranging.
It's a bit windy indeed. Maybe we should go back inside so you can explain to us what it is for.
We want to develop technologies to have better internet, worldwide with higher speeds, to have more accurate knowledge on the position of satellites. I'm looking forward to 2023 when we will have realized this facility.
Me too, Rudolf. A lot of work here is on space applications for a better life on Earth. But it's not all we do. We also explore our solar system and far beyond. Creating and studying ice craters with a gas gun, for example, helps us to better understand how and when the icy moons at the edge of our solar system were formed. One icy moon orbiting Saturn caught our attention because it has geysers, revealing an ocean rich in organic molecules underneath its icy crust. Could it host life? Our researchers are using the wind tunnel to recreate these geysers to understand how they reflect the composition of the liquid ocean. We don't just observe faraway moons, though. We also look at nearby planets. Sebastian, can you tell us more?
Hello, I am Sebastian de Vet and I'm a planetary scientist. And using equipment like, for example, this drone, we can study Mars. Well, actually with a little detour, because this one isn't flying on Mars, but here on Earth. And we can use these drones to map places on Earth that resemble the surface of the red planet. And by doing so, we can actually study landforms like rootless cones that we find in Iceland to better understand the ones that we find on Mars itself. And hopefully in this way, we can actually learn something new about the evolution of the planet Mars.
I'm sure of it, Sebastian. Thanks for visiting the Space Engineering Labs with me. Want to explore some more? Join me on the other lab tours. See you there.